Hello everyone. Today I am going to discuss the sixth problem of AtCoder beginner contest 351, which is double sum. So what is the problem? We are given an integer sequence A of n integers. We have to calculate the following expression, which is maximum of aj minus ai comma 0, iterating over all i's from 1 to n and all j's from I plus 1 to n. The constants guarantee that the answer is less than 2 to the power 63. So this problem statement is absolutely straightforward. What we have to find? We have to find the sum of difference between all the pair of integers if the difference is greater than 0. Okay. So what is the constants? The constants are 4 into 10 to the power 5. So the time complexity for this algorithm, the expected time complexity will be order of n or order of n log n or order of n log square n also. So, let's take one example. We'll understand the problem statement. So let's say 3253. This is the example 3253. Okay, 3253. So for all the i's and j's, so let's consider I and j and diff. So let's consider I, j, d. So 0, 1 and the difference will be 2 aj minus ai, it will be 3. Now 0, 2, the difference will be 3 minus 2, which is 1, and for 1 and 2 the difference will be 0. So the sum of difference is nothing but 3 plus 1, which is 4. So our answer will be 4. So now I am not going to explain the second example. So now discuss about let's discuss about the solution approaches we can tackle use to tackle this problem statement. So this type of problem statements are quite what we can say common, and for this type of problem statement, one trick is to use to somehow sort the array. Okay, so we have to sort the array, but we have to also maintain the indexes. So for that, what we can do, so let's take this. We can take one tuple, which is the first element will contain the value and the second element will contain the index. So let's take this 2 1 5 2 and 3 3. Now after that we'll sort this element. So after sorting this, what will we get? We'll get 2 comma 1 and sorting on the first element. So 2 comma 1, 3 comma 3 and 5 comma 2. Okay, so why we are sorting this? Okay, the algorithm will be quite straightforward. The why we are sorting this? Okay, because let's say we are adding some element 2. So for this 2, there is no element smaller than this. So this 2 will not contribute to any positive sum. Okay, but now we are trying to add 3. Now what will we do? We will check all the elements which has index less than 3 has has value less than 2. Okay, so what we will try to do? We will try to check all the elements which has index less than 3 and value less than 2 sorry, less than 3. So this element 2 has index 1, which is less than 3, also the value 2 less than 3. So what will we add? We'll add 3 minus 2. So you can see that when we are at some index I, we are trying to add its positive contribution to the sum, and all the elements which has indexes less than this, the negative contribution will get added. Similarly, let's say we are at some 5. Okay, we are at some 5. Now the positive contribution of this will get added. Now we can see there are two elements which has sum less than okay. So for this 5, so for this 5 there is only one element which has index less than 2 and value which is also less than 5. So the contribution added here will be plus 5 minus 2. So our answer will be 1 plus 3, which is 4. So how we can solve this problem? The after sorting this, you can do some order of n square brute force algorithm to tackle this to get these desired values by iterating over all the possible indexes from current element 0 to current element. So the solution will be order of n squared, which will be not sufficient. So how we can solve this? For solving this, we will need two things. Okay, so two things we need. So let's say we are iterating over increasing order of values. So we are iterating over increasing order of values. So all the elements added gradually will have lesser values. So let's say we are trying to add the current element. So all the elements previously added which will have lesser values. So we don't have to care that thing, that the value will be greater. Okay, but the index will be greater. So the index will be greater. So we will maintain some type of segment tree or binary index tree for now. Let's consider this as indexes. Okay, so we now let's consider this as array. Okay, so let's say we are iterating over this. Now when we are adding 2 to the first index, so we'll add 2 to the first index. Now when we are adding 3 to the third index, we'll add 3 to the third index. Now we'll when we are trying to add 5, we'll check what are the count of elements less than this. The count of element less than this is 1, and the value of the sum of value of elements less than this is 2. So what we will do, 5 into count, 5 into, let's say current element is ai, so the count will be ai into count of elements less than this minus sum of values, minus sum of values less than this. We don't have to care if the let's say there are some values like this. Let's say something like 4 is present here, or something like uh, 1 is present here. We don't have to care these empty elements because we will consider them as zeros. Okay, we will consider them as zeros, so we can directly take the sum of all the elements till this index, and we will get our desired answer because we are iterating over increasing order of values. That's why we don't have to care about the empty array elements. So we have to maintain two things. One is sum of the all the array elements, one binary index tree to or segment tree to find the sum of all elements, and another binary index tree to find the count of all elements. But we can use one binary index tree with values. Let's say bit i0 will be our sum and bit i1 is our count. Okay, by this we can maintain two binary index trees in a single tree or in single array. So let's jump into the code, you will understand it better. So here I am, this bit array is nothing but our binary index tree. This part is for normal binary index trees. You can search in CP algorithms or Geeks for Geeks about the implementation of this. Now in the query we are also maintaining passing one flag. If the flag is 0, then we will trying to get the sum, and if the flag is 1, we will trying to get the count. Okay, so that's why we are maintaining one base or binary index tree bit, and we'll get the sum and count from the same. So here we are in the v vector we'll pushing the value and index, and after that we are sorting the vector. And then, for every element in the vector we'll take the count as the count from the first index to the current index. Vi1 will be nothing but I plus 1. The binary index is always take the one based indexing. That thing you have to keep in mind. Okay, now we are taking the count, and we are taking the sum here, query of 1 comma vi1 comma 0. Now our answer will be added to count into vi0 minus the sum. Okay, now after doing this we have to update the current index with the current array element. So this update operation will also change the count. Okay, I hope you get it, and at the end you have to print the answer. So the problem is quite straightforward, and I think this type of problem I have solved before, but I don't really remember which problem was that. I will also provide the link of the code in the description box. If you have any doubt in any part of the explanation or code, you can always ask in the comment section. Also, if you find this video helpful, please like the video and subscribe to my channel. Thank you.